Okay, well, we shall begin. Happy Monday, everybody. It's another Monday, week 2. So I hope by now you're feeling comfortable with getting stuff from Git. So, on your computer, you're going to kind of change, wherever your directory is that you've stored it. So maybe that's on the desktop. Here, I just have my 2024 Fall Stats 21 folder in my home directory, and right now I just have through 1.3. I've updated a couple things, so I'm going to just do a git pull upstream main. All right, and so that's going to go to the professor's repository and pull the latest stuff. So git pull upstream main, and basically the new file that has been uploaded is 2-1 functions in Python. And with that should be there. I mean, if you want to push to your own, you can do a git push, and that will push to your own personal repository on GitHub. And then once you're done with that, you can kind of exit out. And then if you open it up, it should look like this. So here I am in VS Code. And again, on your computer, you can run things in VS Code, or you can run it in Jupyter Lab. And run things there. So, but the notebooks, I think, hopefully the notebooks are running, and you can take a look. So today we'll talk through, functions that exist in Python, and just kind of the concept of having inputs and outputs and all of that. So. A lot of this is coming from our textbook, Think Python, and then also another kind of handy book is a Whirlwind Tour of Python, which is also available for you to read for free as long as you kind of log in through the UCLA library. So this is true for all programs, everything on the computer, and this includes every single video game you've ever played, every application, it can be reduced to basically the following set of instructions. One is we get input from something, okay, either from the keyboard, a file, network, some device. You're getting some kind of input, all right, and that might be just stored in files and things like that. Every program has some kind of output, display data to the screen or save to a file, send a file over a network, okay? Some kind of math is being performed. And then we have conditional execution, basically check for certain conditions, and based on those conditions, run the appropriate code. And then repetition, usually basically do the same thing, but slightly different, okay? And that's what you have. And basically, we'll look at some simple examples where we have inputs and outputs, but, even like the most advanced video games can be boiled down to this. The output on a video game is basically every single pixel. So if you have a 4K video game going on, you've got thousands of pixels, and you need to update those pixels, 60 times per second. So, we're talking, millions of pieces of information. But it's basically what color should this pixel be, right? How much red, how much green, how much blue should be in that pixel. And basically, if the computer is able to do all of those calculations very well, then it's going to look like you are immersed in some world or something like that. But it's basically just math being performed, so that every single pixel gets a new number 60 times per second, and then it looks like you're racing a car or whatever it might be. Okay, and basically that kind of math that gets performed gets more advanced, ray tracing, whatever it might be. But anyway, at the very basic, we have these functions. Okay, function calls is basically when we tell the computer to execute a function. So function calls are how the functions are executed. And basically, when we call a function, it is we give the computer the name, okay, the name of the function, and then we give it any kind of arguments, values that need to get passed to the function. And we put those arguments inside a parenthesis. And then that function runs its code, and a lot of times the functions will produce a value that it returns to us. So there's kind of this, I ask for something, and then the function gives me something back. Okay, not always the case, but that's frequently how it works. All right, so I make a call to the function, and then it does something, and then it gives me a response. Okay, and that response is the return value. So here I can a very simple function is type, and I just ask the function, hey, what is the type of value that I'm giving you? All right, so here the name of the function is type. I'm giving it the value 42. All right, and then this function says, all right, this input that you gave me 42, that is an integer type. Okay, the type of data that you've given me is an integer, so it returns back and it tells me it's an integer. Okay, and so that is the value that it returns. Okay, if you write the name of the function but you don't put in any kind of parentheses, that doesn't call the function. Okay, it's just asking, hey, what is this thing? Okay, this doesn't call the function. This is the object itself. So if I just write down print, okay, with no parentheses, it doesn't call it, and it just says, oh, print, that is the function called print, right? So it's kind of like talking about a person versus using that person's name to call that person. Okay, so we're just talking about the function print. We're not actually calling on the function print here. Okay, whereas here is when I put in parentheses, now I'm saying execute this thing. All right, so here I'm going to say print parentheses, and then inside the parentheses I put in the argument. Here I put in the argument, which is just the string hello, and so this executes the function print, and it produces the output hello, okay, onto the screen. Okay, so this is actually not a returned value, it's just output to the screen. You can call other things. So here I can provide basically a sequence, a tuple of values 1, 2, 3, and I can execute that, and it prints 1, 2, 3 to the screen. There are optional arguments. One of the optional arguments in print is the separator argument. So by default, if you give it multiple things, so here I gave it 1, 2, 3, and by default, it separated the 1 and the 2 and the 2 and the 3 with a space. Okay. And you could provide different arguments, and you could say, hey, instead of separating it with a space, separate it with this little dash or hyphen character. Okay, and so it will do that. It'll say, okay, here's 1, 2, 3, but instead of spaces, I'm using the hyphens there. At any time, you can kind of reference, get help by calling help on the function. All right, so you can say help print here. Let's see, can we? Actually, I don't know how to use help in VS Code, but you can do that in Jupyter Lab. You can hit Control I. I don't think it's not the same on VS Code, but in Jupyter Lab you can hit Control I, and it'll bring up a little extra pane for help. And then you can always go online, and you can type in Python reference like print. Okay. And so you have basically documentation. This is the Python tutorial, but you can ask for the reference for any of these things. So here, 3.12, I guess now we're up to 3.12.7, and you can always look at kind of the library reference, and you can always search for whatever it might be, okay? All of these different functions. So docs.python, this is going to be a good place to get started there. Okay, so anyway, this is just kind of your built-in help. It says, You can give it arguments. Star args is basically saying any kind of arbitrary number of arguments, and then you can also provide it additional arguments such as the separator, the end character, file, flush, things like that. And so here we saw changing the separator. End is after the last thing gets printed. The default is to put a new line, which basically just terminates the thing so that the next thing that starts will be on a new line. But if you want it to have a different end character or ending, you can do that. The default output is to the screen, but if you want to output to a file instead, you can specify that and things like that. And then flush is to forcibly flush the screen if you need to. That's a little bit more relevant when you're outputting to a file. Okay, just a little side note about single and double quotes. So as we're defining strings and whatnot, we've got quotation marks, and you can define things with double quotes. Okay, and if you have double quotes, then you can put in basically the single quote mark as in place for an apostrophe, because on the keyboard we only have on the keyboard you have a single straight quote and a double straight quote, which a lot of kind of word processors will intelligently figure out, and it'll change from the double straight quote into a double opening quote and a double closing quote as necessary, or it'll change the single straight quote into an apostrophe and things like that. But when you're typing, it doesn't. Into code, it just looks like this, right? So here I can put in an apostrophe. I put in "I can't believe it" here, and that's fine. But if you can also open and close quotes with single straight quotes. But if you do that, then trying to include a single straight quote here is going to close off. It's going to close off the first quote, and then you're going to run into a problem here. And so this causes a problem. It says unterminated string literal because we've got "I can" close quote, and then it sees all of this extra text. T believe it exclamation point, and then an opening. It interprets this single quote as an opening quote, and it never gets closed, so it doesn't like that. If you want to include, if you want to use single straight quotes to open and close your quotes, but you want to include basically an apostrophe mark in there, you can escape it with a backslash. So you can do that, and that gets interpreted correctly. All right. You can also kind of do the reverse, and you can put in a double quote here, but this is confusing to see "I can" double quote T. That's confusing. So if you do want to include things like closing quote apostrophes or quote marks or whatever, you use the backslash to what we say escape it. So that it tells the Python interpreter, don't read this as this closing quote doesn't close this quote mark. We want it to be a literal in there. Okay. All right, we can define new functions here. Actually, let me give you your first view quiz answer. Letter B. B as in bear is your first view quiz answer for week 2 Monday. Okay, so we can define a new function, and you use the keyword def, okay, to define a new function. And then when you do that, you provide the name of the function, whatever you want to call it, and then any kind of arguments that you want to provide, and then a quote, colon, all right? And that's the opening line. And then once you put in that colon, any code that is indented will be associated with that function definition. And then as soon as you stop the indentation, that terminates the function definition here. If you want your function to return something, you have to use the return statement. So here, my function is going to be called shouting, it's going to accept a phrase as its argument. And then what it will do is it's going to basically do phrase.upper, which takes a string and turns it, makes it all uppercase. And then here I have plus exclamation points. So it's going to add, tack on, concatenate some exclamation points to that thing. That gets stored in as this argument or variable shout. We get so many people coughing. And then we're going to return that shout, okay? So we're going to call define shouting phrase. So here, that just creates the function here. And if we want to execute it, now I have to call it. So I'm going to do shouting parentheses, and here I put in the quote, "Hi, my name is Miles." And then when I execute this, what it's going to do is it's going to take that, make it uppercase, add a few exclamation points, and then it comes out here, right? "Hi, my name is Miles," and it's just the way, I don't know, the way we read text now. It really feels like I'm shouting at you or something like this. Okay. Here, if I try to execute shouting on the number 5, okay, it raises an exception. I get an error here, okay? And that's because the number 5 here as input is an integer. And integers don't have a method called .upper. So .upper is something that applies to strings. And so, if you say, hey, what is uppercase 5? It's a little bit of a confusing thing, right? So you're like, there's no uppercase 5, there's no upper or lowercase 5, and so basically that's what Python complains. It says integers have no attribute upper, okay? And so what we can do is we can just tell Python, hey, anything that comes in, whatever this phrase is, make it a string first. So the only difference between this code and this code is that here I did phrase.upper, and here I say, hey, string phrase.upper, and that's going to kind of take whatever came in, whether it's an integer or whether it's a string or whatever, it's going to kind of convert it into a string first. And then it's going to say, okay, now that you have this string, make it uppercase, okay? So now we're just going to say, take that number 5, treat it as if it were a string, and then make it uppercase. In this case, there's no uppercase 5, but it'll do it. And then so now we have shouting on 5, and then you're just shouting 5, okay? And so that's what we have there. Okay, all of these functions, I've used this line return, okay? And so this means the function is returning an object, and that object can be assigned something, okay? Assigned to another place, and then we can do that, right? So here again, here's the same function, and I can call greeting is equal to shouting hi, and then so shouting hi is going to get assigned to this variable called greeting, okay? Now when you, in Python, when you assign something to a variable, Python doesn't output anything to the screen, it just does it, okay? And so it's done, and then later on, if you want to make use of it, you can just ask for that thing, and you can say, hey, what is greeting? And it says, yeah, it's right here. Greeting is hi, exclamation point, exclamation point, exclamation point, okay? So we have that, okay? Here, I'm going to have another function, but this time I didn't use I don't say return, okay? I just say take the phrase, make it lowercase, and then and we store it, and then the last line of the thing is whatever I've stored it, the SHH, the sh here, but it's not being returned. So when Python executes this, it just kind of sees this, but it doesn't do anything with it. It doesn't return anything, and when it reaches the end of code for the function, without encountering a return statement, it's going to return a none object. Okay, it's going to return a none object. So that's basically Python's way of saying, like, there's nothing to return. So in R, the equivalent concept would be the null, and Python instead has none. Okay. So here, if I try to say, hey, run quiet on hello, okay, it's going to execute this, okay, but then this returns none, okay? The function returns nothing or returns none, and so what gets assigned to Whisper will be the none object, okay? So here if I ask, hey, what is Whisper? When you ask what is Whisper, nothing comes back, okay? When you call, like when you ask, hey, what is in this thing, and the object is nothing, then or the none object, then nothing gets output to the screen, okay? Now you can kind of forcibly ask, print whatever that is, okay? And then it will say that there's a none there, okay? So there's nothing, and you say, hey, what's in your hand? You say, well, I don't have anything. Give me what's in your hand, okay? I don't have anything to give you in my hand, right? And then you say, no, give me what's in your hand. Open up your hand. You open it, and there's nothing in there. But that's basically what we're saying. We're saying like, okay, what's in your hand here? There's nothing. So there's nothing gets returned. None gets returned here. And then when we say print, just show me. All right, you open it up, you go, okay, there really is nothing in your hand, right? So that's what we have. You can ask, hey, what is the type? The type on the none is the none type, okay? And that's what we have. And so this function, again, because we didn't return anything, it returns none. So that's something to just kind of keep in mind. When you call print in Python, print also returns none. Okay, print will output stuff to the screen, so it looks like there's stuff, but print returns none. So if you try to like assign the value of print somewhere, it doesn't exist anything. And if you try to like make use of whatever it's done there, there's nothing there. Okay. You can return more than one value. A function can return more than one thing, and if it's going to do that, it returns them as what's called a tuple. Okay, a tuple is a data structure, kind of like a list, but the order is a list is mutable. A list can be edited, and tuples cannot. But it's basically just a structure that we have that is able to contain multiple values here. So here I'm going to create a function. It's going to be called powers of, and we put in a number, and we're going to calculate the square by doing the number to the second power. We're going to calculate the cube by taking that number and returning it to taking it to the third power, and then we're going to say return the number, the square, and the cube. Okay. So we do that, and then when we call powers of on, say, the number 3, it's going to return all 3 numbers. It's going to return the number, the square, and the cube. So we get a tuple of 3, 9, and 27. Okay, so you can return multiple values, and they just get gathered in a tuple. A neat little thing is you can perform what's called tuple unpacking. Okay, so here I've got powers of 3, and I'm going to assign the output of powers of 3 to x, y, z. And Python is going to see this, x, y, z, and it's going to unpack the 3, 9, and the 27 and assign these things respectively. So 3 is going to get assigned to the x, 9 gets assigned to y, 27 gets assigned to z. So if I do powers of 3, I'm going to unpack it to x, y, z, and then I can say, hey, what is x? So I print out x is 3, print out y, and print out z. It says 9, and 27. They're all kind of stored separately. One nice thing in VS Code is you have this variables view, and you can kind of see the different variables that exist. And so we have x, y, z, 3, 9, 27. All right, and then Whisper is also none type and things like that. So you can also, instead of separating them out, you can also just capture them as one single output. So here I've got powers of 4. I'm going to just assign it to j. And so j is going to contain the entire tuple of 4, 16, 64, right? So this is going to be just one object, and it's the tuple with three values in it. So you have the choice of either unpacking, or you can store that. Okay. With the tuple, you can, if you wanted to access this value 4, you can say, hey, give me the first value. In Python uses 0 indexing, so position the first position is index position 0. So you can say, hey, I want the index position 0 value, the first value. So you just do j square bracket 0. So a lot like R in terms of subsetting a vector, you use a square bracket with an integer in there to say, hey, I want the value in this position. So j position 0 is going to be 4. J position 2 will be the value 64, and you can, again, just kind of use those as you see fit. Okay. If you are going to do tuple unpacking, though, okay, then you have to provide the correct number of arguments. So in this case, the tuple is length 3. So if you want to unpack it into, say, x, y, z, you do have to provide 3 arguments. If you try to do something like this, I'm going to do powers of 5, and I try to unpack it into g and h, right? So powers of 5 is going to be 5, 25, 125. There's going to be 3 values there. If I try to unpack it into just 2 things, g and h, then it causes an error, right? It says too many values to unpack, expected 2. So Python reads left to right, and so it says the g and the h equals. So it says, okay, I've got 2 values, I've got a g and an h, and I want to unpack to those 2 values. And then it says powers of 5. Uh-oh, powers of 5 have given me 3 things. And so it says, you've given me too many values to unpack because I was expecting 2, and then and you gave me 3. So it says, this line of code is no good. So, one thing that I put in your homework is like, give me details on the errors and stuff. I'm not asking for like super detailed responses for that, but I do want you to get into the habit of reading through the error messages, because inevitably, as you code, you will make mistakes and you will encounter error messages. And beginner programmers have a tendency to, when they encounter an error, just throw up their hand and say, I don't know what to do. Okay, but a lot of times there's a lot of good information in that error message, right? In Python especially, it will highlight exactly what line of code causes the error message. It will give you some kind of description of what's going on, and then try to read that line and try to understand what's going on. If you are still having trouble, you can always kind of highlight that error message and then search for it online and see what that means. And hopefully that will at least point you to where you can start making corrections. Now, the caveat is, as we start loading up packages later, like NumPy and Pandas and things like that, there's going to be a lot of code that you yourself haven't written. It'll be like code that's part of these packages, and then you encounter an error message, and then it'll be a lot harder to read because it'll be like, we executed this thing, and it called this thing, and it called this thing, and this is where the problem lies. Those error messages are a lot harder to read. But again, the same kind of principles of like, okay, if you're not sure, you can always kind of look up that help message and see if you can find, or look up that error message online and see if it can point you in the right direction. Okay. So a lot can be learned from reading error messages. As we, I guess an important thing to remember as you read your Python code, whether it's code you've written or what someone else has written, is that the way Python executes is it always kind of starts at the top and it reads left to right and it goes line by line by line. Now, one thing is that when you define a function, it doesn't execute the function at the time you define it, okay? It just says, okay, here's a definition, and it's only going to execute the lines of code in that definition when that function gets called, okay? So the statements inside the function don't run until the function is called. So a function call is like a detour in the flow of execution. Instead of going to the next statement, the flow of the execution will jump to the body of the function, and then it runs the statements there, and then it continues where it left off. Okay. So so here is just a silly function. It says print twice. The argument is called Bruce, and then what this function is going to do is it's going to take whatever that argument Bruce is, it's going to print it, and runs one line of code, and then it runs the same line again. So it's going to just run that thing twice. So it literally just prints it twice. So if I call print twice on spam, it's going to print spam and then spam. So this is the author of Think Python, I guess, is a fan of kind of the British humor group Monty Python, and I don't know if you've ever watched any of these old movies and stuff with like Monty Python and, you know, the Holy Grail and Life of Brian and things like that. But anyway, one of the running jokes is spam and, you know, the Spanish Inquisition and things like that. So, but anyway, that's what these things are referencing. Like, why are you using these terms here? Okay, so anyway, print twice. We put in the argument spam. It prints spam, and then it prints it again. And we have that, okay? Here I'm going to call import math, and we're going to call calculate, pi over 2, ask sign of what pi over 2 is, you know, and we'll print that twice. And it says, okay, that's 1, 1.0, 1.0, all right? Here, what would happen if I give it spam space times 2? So first it's going to execute, it's going to evaluate what's inside the parentheses here. So that will be spam, spam, right? Spam space, and then it's going to print that thing twice, okay? So there's also a space after that spam there, okay? So that's what we have there. Okay, now what's going to happen here? I've got print twice spam inside print twice here. Okay, so this is going to do a little bit something strange, okay? Well, I don't know if it's strange, but it's doing exactly what I asked it to do, okay? Which first it's going to print twice. It's going to, when you give code nested inside other code, or functions inside other functions, it always starts with the innermost thing. So it starts off with the innermost thing, and that's going to run spam, print twice spam. So we call print twice on this inner part, spam, so print spam and then spam. Okay, what does print twice spam evaluate or return? Okay, this function, because it doesn't return anything, okay, it just runs these print statements and doesn't return anything, what it returns is a none. Okay, so now it's effectively calling print twice on none. Okay, and so then it executes that, and it prints out none twice. So it's kind of like back here when I said, you know, what's, you know, this whisper thing, it doesn't return anything, so it returns none, and I say, hey, print that out, it just prints out none. And then now I've asked it to do it twice, so it prints none twice. So it prints spam twice, and then it prints none twice. So the computer might not do what you expected, but it always does what you exactly what you asked it to do. And what we asked it to do is print spam twice, and then because print twice returns none, and we asked it to print the whatever returned twice, it's going to print none twice. All right, let me give you your second answer, and your second answer today is the letter B. The letter B is your second answer. B. Also B. Okay. When you define a function, okay, here you can give it arguments, and this is just a dumb function. We're going to call it stuff, and it takes in 3 arguments, A, B, and C, and then this function is going to return, or not return anything, but it just prints out A, B, and C. So this has no defaults. We're going to call stuff 1, 2, 3, and it prints 1, 2, 3. If the function is defined to accept 3 arguments or require 3 arguments, and you try to execute the function without providing all 3 arguments, you get an error. So here, stuff requires A, B, and C, and I'm calling the function with just arguments, with just 2 arguments, 1 and 2. And so here it says, hey, you know what? You're missing an argument, a positional argument. So the argument, it says, okay, 1 went to A and 2 went to B, and then I'm expecting something for C, and I don't have anything for C, so I can't do this. So it says you're missing something here. Okay. Now here you can provide default values by, in the definition of the function, you provide equal sign for each argument, and that's going to be a default. So basically, if that argument is missing, it's going to use the default. So here we're going to define junk with A equal 1, B equal 2, and C equal to 3. We'll just print those out. So if I call junk with nothing, it's going to print using A, B, and C are 1, 2, and 3, and prints out 1, 2, and 3 here. Okay. If you provide just one argument, or if you just provide a value, it's going to assign it positionally. And so it'll go 4 goes to A, and then it'll use the defaults for B and C. So we'll get 4, 2, and 3. You can also kind of specify, and you can say B equals to 4, and then it will use the defaults for everything else. So we get A is 1, B is 4, and C is 3. You can provide all 3, 5, 10, and 0, and then you'll get A is 5, B is 10, and C is 0. So that's fine. Okay. Python doesn't like if you name some of the arguments but not the others or something like that. So here if you do 5 is this, A is 10, and B is 0, it's going to get upset because it's going to take, again, read left to right. So it says, oh, you gave me a 5. I'm going to put that into position, the first position, A. All right? And then it says A is 10, and it goes, oh, wait a second. You already gave me a value for A, and I plugged in 5, and now you're giving me 10. So, it gets unhappy, okay? So it says, I got multiple values for argument A is the thing, right? It says, I took 5 and I assigned it to A, and then you gave me A equal to 10, and I don't like this, okay? So you get an argument, an error there. Here I got, you can provide if you name all of them, C is 5, A is 10, and B is 0, you name all of them, then Python is okay with that. It doesn't get angry with you, okay? So you have that. Okay. Function variables and parameters. So when you execute a function and you have variables inside that function, those things are local, okay? So here I'm going to create a function called print twice, all right? This just takes that argument Bruce, prints Bruce, and then prints Bruce again. And then cat twice, okay, is going to take 2 things, part 1 and part 2. It's going to cat them together. So basically, it's just going to take those 2 strings, tack on a space in between them, and we're going to call that a cat. And then it's going to call print twice on cat. Okay, so whatever that is, it's going to take print twice, and it's going to do that. Okay, so here I take line 1 bitty bitty and line 2 bomb bomb, and we're going to say cat twice. So what it's going to do is it's going to take line 1 bitty bitty and then add tack on bomb bomb. Okay, and then so that's going to be cat, and then it's going to print that twice. Okay, and then we'll get that. Okay. So when that is done, okay, this variable cat, okay, it disappears with the execution environment, right? So when this is running, we have this variable cat, but it's only exists inside the scope of this function. Okay, if I try to ask, hey, what is cat later? Okay, this doesn't exist, right? Because it's not defined outside of the scope of the function. Same thing with Bruce. Okay, Bruce is not defined. outside, okay? So these things, these variables and stuff, all of the arguments, they get defined inside the scope of the function, but they don't exist outside of it. And so you can't reference them later, okay? As you encounter things and you, if you encounter, so here I've poorly defined this function. I'm calling print twice on Bruce, but then I'm gonna, inside the lines of the code, it's gonna say print cat, okay? And so we're gonna see this is gonna run into errors here, right? And I say define cat twice, and it's gonna do this, and it's gonna print twice on cat. So here, if I try to do this, then we're gonna run into an error. Now, as, again, I want you guys to get comfortable reading error lines. So when I call cat, okay, it says this is where we encounter the error, right? So line 1, bitty bitty, line 2 is equal to bomb bomb, no problems there. When I called cat twice, that's where I'm encountering an error. So it goes into the definition of cat twice. Inside the definition of cat twice, it says you called part 1 and part 2. Cat is equal to part 1 and part 2, and you called print twice on cat. The error is encountered inside this line, print twice cat, and inside print twice cat, what we've done is we're executing the print twice function, and we encounter this thing print cat, and it says cat is not defined. Okay, so it says this is where we are encountering the error. Okay, cat twice. So here's, it says, you know, in this cell, this is where we're encountering the message on print cat, okay? And if it says, you know, cat is not defined, okay? And we can see that, yeah, indeed, inside this print twice Bruce function, there's no definition of cat. So that's where we're encountering the error message, okay? Here, if I just define cat in the global scope, and I just call this something else entirely, right? I could execute this again, and this will run, okay? So, you know, I've passed bitty bitty and bomb bomb here, but again, when I execute print twice on cat here, this just gets, bitty bitty bomb bomb gets passed in as Bruce here, but then when it executes this line here for print cat, it's not going to see Bruce, okay, which is the bitty bitty bomb bomb. It's going to look into the global environment, and it's going to see this something else entirely, and it's going to print that twice. So it's something else entirely there, okay? Okay, as you're executing your thing, you can kind of see a list of basically all of the objects defined in the global environment. So you can call %who, and that's going to give you basically all of the variables that exist. You can get more details by doing %whos, and you can also do %who underscore ls, and this will provide it as a list. Again, in VS Code, you also have this little variables button, and it gives you kind of the same information here. So it tells you you have all of these things. So this will just be kind of the variables. It doesn't show off the functions that you have listed, but oops, kind of a just kind of a nice handy little feature in VS Code where you can kind of see these things defined as well. Okay. But yeah, if at any time you want to see, hey, what are the variables or the things that you have defined in your environment, you can call %who or %whos there. Okay, so just a little bit more on some of the scoping rules here. I'm going to define the variable x. We'll give it the value 5, and so x takes on the value 5. Here I'm going to create a function. It's going to be called alter x, and we're going to do x plus 1, assign that back to x, and we're going to return x. So when I call this, okay, we're going to pass in alter x on x. It's going to take 5. It's going to add 1 to 5, assign that to x, and return x. So it's going to return the value 6. Okay. However, remember, keep in mind, this is just inside the local scope. So the actual value of x in the global environment remains unchanged at 5. right? So this x that got changed to 6, it only got changed to 6 inside this function alter x, okay? Whereas if you want to change the x that exists in the global environment, you can do that. And so here I've got alter global x, and here I use the keyword global, and then that says, you know what, don't use any value of x that's defined inside this function, but make use of the one in the global environment, okay? So here I'm going to say global x, then take x plus 1, add x, add 1 to it, and store it back to x and return x. So here I got 5, x is 5 in the global environment. I'm going to call alter global x. It returns 6, and then the x in the global environment indeed has been updated to 6, okay? So that uses the keyword global. Be very careful using global, okay? In general, I recommend not using global because when you start messing things in the global environment, you really have to start keeping track of a whole bunch of things in your head, because most of the time when you call a function, you're expecting it to just kind of modify stuff inside the function. And if you're starting to modify things globally, it's kind of hard to keep track of it. So if you're going to modify things globally, you want to, at least the name of your function to kind of give you a hint that it's going to modify something globally and things like that, okay? In this function, we're going to ask Python to print the value of x even though we don't define the value of x. And so this is basically going to search for x somewhere in some kind of scope, all right, and then print that value and return that value. So when we search for x, it's going to search for the value x, and it finds it in the global environment. It prints it out, 6, and it also returns that value x here, okay? The scope order is it goes LEGB, all right? So it starts on the local scope, okay? It's this is going to be the code block or body of the Python function itself. That's going to be all of the names defined inside that function. If you have if that function is nested inside another function, that's known as the enclosing thing, okay? So you have the non-local or the enclosing scope. That's going to be if a function is inside of another function, okay? And if it can't find it there, then it will search the global scope. That's the kind of the topmost scope in the thing, basically everything in the global environment. And then if it's not there either, it's going to search kind of the built-in kind of names of Python. So you know. Functions like list, where you use it to create a list, or functions like dictionary, dict, to create a dictionary, and things like that. So it's gonna search for those things out there. So here, let's see, I'm gonna run out of time. I got XYZ in the global environment, and I've got a function y. We define y to 2 inside the local thing. We're gonna return x, y, and z. And so when we do that, when we call f here, it takes the local value of y to be 2, okay? But in the global environment, x, y, and z still remain 1, 1, and 1, okay? Here I've got f, and inside f I have y is 2, and inside g, z takes the value 3, and this is going to return x, y, and z. So again, when it executes this thing, it's going to find the local values. And if it can't find the local value for y when it executes g, it returns, searches the higher scope. So it's going to return 1, 2, and 3. And then, but again, in the global environment, everything is unchanged. Okay? And over here, something very similar, but also different. Here, f is not defined inside of g, and g is not defined inside of f. So here, when I call function f, and inside function f, I call g. Okay, when I execute g, it's going to use the local value of z for 3, and it's going to search for x and y here. When it searches for x and y, it's going to just go straight to the global because g is not defined inside of f. G is executed inside of f, but it's not defined inside of it, so it's never going to find this value of 2 inside of f. Okay, so here it takes the value for 3. But not for y, okay? And so here, just some more, I'm out of battery, and I'm out of time. Here, I use the keyword global, And so when I use the keyword global there, then it's going to modify things in the global thing. And so z gets the value 3 and so on. Okay, you can kind of go through these examples on your own time. These are just more examples of kind of local and global scope for you to kind of play around with. So even though we're out of time, I think you can kind of go through and study those examples of code. Okay, let me go ahead and give you your last ViewQuiz answer.